And so then I want you guys to kind of look at this and try to find the error. So please pause it before I move on. I'm going to move on for the sake of time. So this one, it says then correct the statement for the conclusion. So they're saying that ty is equal to tz. Well, what is the error in their thinking? Well, the error in their thinking is that first, that point T is the incenter of the triangle. It is not the incenter of the triangle. It is the circumcenter of the triangle. The incenter comes from bisecting the angles, which then the Ty and or TV and TZ would be the same. But since it's not angle bisectors, it's actually perpendicular bisectors. This is the circumcenter that draws the circle around the outside. That would mean that to correct this statement, you'd have to say something like TW will be equal to TU or TY. Okay, so basically all the lines that aren't drawn in there would be equal to one another, because this perpendicular bisector gives us the circle that draws around the outside, which is the circumcenter, which means that the distance to the vertices from that point are all the same length. That's from our theorem. You can look back if you need to. All right, so then it says find the value of x that makes n the incenter of the triangle. Round to the nearest tenth. Okay, so we need to find x, so that is the incenter. Well, what do we know about the incenter of a triangle? Well, the incenter of a triangle cuts the angles in half. It comes from the angle bisectors. So I'm going to draw in my little angle marks. Sometimes you'll see it like this. There should be 3 there, 3 angles there. So we now have 3 different angles that are all bisected. So there's my incenter. What do we know about the distance nj? What do we know about nj compared to nl compared to nk? Well, from the incenter, we know that all of these guys are equal, and I know that just from the terminology. So now, if I know that all of them are the same, nl matches nk, then I can go ahead and do my Pythagorean theorem, because I have a right triangle, which means 35 squared, it's supposed to be a square, plus 2x squared will equal 37 squared. Whoa, that was a bad 3. Sorry about that, guys. And that's even worse. So let me try again here. 37 squared. So now I got to get out my calculator, because I don't know these guys off the top of my head. 35 squared is 1225. So 1225 plus, this becomes 4x squared. I square both terms. So 2 squared is 4, x squared is x squared, equals, and 37 squared I got to find. 37 squared is 1369. So 1369. Whoa. Sorry about that. I don't know what's going on with my handwriting here today. And so now, solving it algebraically, I'm going to go and subtract 1225 across the equal sign. So now I got to go back to my calculator here. And I'm going to take that 1369 and just say minus 1225. And so I get 144. All right. So that means that 4x squared equals 144. If I divide 144 by 4, I'm just going to go divided by 4, gives me 36, which means that x squared equals 36. And then if I take the square root of both sides, that means that x is 6. We didn't even need to round to the nearest tenth. They were trying to throw us off on that. And so x is 36, which means that, well, that's not the whole length of NL, because that's what they're asking. 36, 6 is x, so that means to find the length of NL, NL is 2 times x, and L is going to be 2 times 6, which is really 12, which is really what we want. So there's my final answer for that problem. So you got to make sure that you read the questions carefully and go all the way through them. All right, so then we're on our final one here. I believe our final example. It says, you are constructing a fountain in a triangular koi pool. Kois are the fish that are down there. You want the fountain to be the same distance from each edge of the pond. So the fountain we're going to put in the middle is going to be each edge. So we need to figure out what gives us the fountain in the middle so that it is equidistant from each edge. Well, what does the word edge mean? Well, that means side, right? And so if edge is side, then we need to find the point that is equidistant from each side. Well, how do we find the point that is equidistant from each side? That's the angle bisectors. And so we draw in our angle bisectors, and I'm going to do my best here to draw some angle bisectors. See, try to cut this guy like that. Try to make my angles look the same. So there's one. Looks like those guys are the same. And then if I draw this one going through that point, that looks like I bisected all the angles. And so by cutting the angles in half, this point right here would be my point where the fountain would go, so that it is equidistant, because we remember that from that point we are now, if I could draw a 90-degree angle to the sides, let's see, a 90-degree angle to each side, each one of these lines should be pretty much, and I don't know how I did, I think I'm off. I think this pink one here should be a little more over here. Still, but anyway, you get the idea. Each of them should be the same length, and that's the whole idea, is that each one of these guys, because we're finding the in-center, we're finding equidistance to the side, each one of those guys should be the same length. And so that's what we're trying to do. And so let's check on the reasoning. It says, build the fountain where the angle bisectors meet, which is equidistance from the three sides. That's what we're trying to do. Okay, so then out, it says, describe how you find the in-center of the triangle. Well, that's what we were just talking about. And so the in-center of the triangle, again, is using the angle bisectors. So bisect each angle, bisect each angle, and where the three lines are concurrent, three angle bisectors are concurrent. Wow. Are concurrent, then that is the in-center. Thank you very much for listening to our webinar. Hope you guys have a good night, good day, and I will see you guys soon.